This is text problem 9-6, and we're given a table here with the annual growth rates for 3 different countries over the course of 4 different years, from 2015 to 2018. And we're told that each of these countries started with a real per capita GDP equal to $20,000. So the first part of the question says, the nation that most likely experienced a sizable earthquake in late 2015 that destroyed a significant portion of its stock of capital goods but was followed by speedy investments in rebuilding the nation's capital stock is. So we know that if we're looking at a big natural disaster like an earthquake, we can expect to see a drop in the growth rate for that country, right? Because it's probably going to destroy a whole bunch of, like it says, a bunch of the capital goods, which would be the machines and buildings and things like that that are used to create or to make consumption goods. And when those things are destroyed, the country can't grow as fast as it was. So we're looking for a country that was growing pretty fast or growing at some rate, and then after 2015, the growth rate drops sharply. And then we see it start to climb back up after these speedy investments in rebuilding begin to occur. So it looks like from the table here that we're talking about country X, because country X was growing at an annual growth rate of 7 in 2015, and 2016 dropped sharply down to 1. And neither of the other two, Y actually grows faster in 2006 than 2015, and Z only goes down by 1%, as opposed to country X, which goes down significantly for 2016, and then just starts to grow back up in the following couple of years. So I'm going to say we're talking about country X here as the one that had this huge natural disaster that would have shaken the country and knocked its growth rate down. Now, for the actual math of the problem, they say, all right, calculate the nation's per capita real GDP at the end of 2018. So that's our final year, right? We know that we started with a real per capita GDP equal to 20,000. And each year we grow at the rate that's given here. Remember, the rate given is a percentage. So we know that in 2015 we grew 7% of what we started with. And we started with 20,000. I'm going to get Excel to help me with the math here. You see, I've already put in the numbers for country X, the growth rates. So the question is, what is my GDP at the end of each one of these years? So I'm going to put another row in my table here for GDP at end, or at year end, we'll call it. So at the beginning of 2015, we had a GDP of 20,000, we were told. At the end of 2015, what's our GDP? We know it grew by 7%. So what we need to do is find what is 7% of 20,000 and then add that to my 20,000. And I know that's what my new GDP per capita is, or real GDP per capita is. So how do I find 7% of 20,000? I just want to take 20,000 times 0.07, right? So I'll get Excel to do that for me. 20,000 times 0.07. That's my 7%, right? You want to always change it into a decimal before you do this math. So to change a percent into a decimal, you just divide by 100 or move the decimal over 2 places. So I'm going to multiply by 0.07, and I get 1,400. Is that my new GDP, though? No, because that's how much my GDP grew. So I take what I started with, and then I want to add this to it. So in fact, what I have is my 20,000 times 0.07, and then I want to add to it my 20,000. Or another way to look at this is that I'll multiply by 1.07. And this is similar, if you're freaked out by this math, this is similar to calculating, say, tax on a shirt that you buy at the store, right? So say your shirt costs $20. We'll take this 20,000 and make it down to a 20. Say your shirt costs $20 and you pay 8% tax, right? How do you figure out how much you're going to pay in total? You multiply by 1.08, right? So same thing's going on here mathematically. We started with $20,000. We increased by 7%. So think about your shirt. You started at $20. You increased it by 8%. So you want to multiply by 1.08. Here we want to multiply by 1.07 to increase by 7%. Right? Simple enough, right? So we want to do the same thing in 2016. Now we know we grew by 1%. But what grew by 1%? The amount we started with at the beginning of 2016, which is this number, the 21,400. At the end of 2015, we had 21,400. So at the beginning of 2016, that's how much we had, right? So now we want to take that number, the 21,400, and we want to multiply it by 1.01 because we're growing by 1%. So now you think about your t-shirt having 1% tax on it. So you multiply by 1.01, right? So we're doing the same math here. We just have a different starting point now. The starting point for 2015 we were told was 20,000. The starting point for 2016 we know is whatever we ended with at the end of 2015, which we already calculated was 21.4. So at the end of 2016 we have $21,614. And we want to do the same thing 2017 and 2018. In 2017, we started with what we ended with in 2016. So we started with this 21,614, and we're told we grew at a rate of 3%. So we want to multiply by 1.03 to get the amount that we had at the end of 2017. Finally, for 2018, we'll take the amount we started with, which is the amount at the end of 2017, times our growth rate was 4%, so 1.04. And now we have the amount, or our real per capita GDP at the end of 2018. See, what we had to do here was just grow each year by the percent we were given, right? So the first year, we knew we started with 20,000 and we grew by 7%. The second year, we knew we started where we left off the year before, so we started at 21.4 and we grew by 1%. So we multiplied by 1.01. The third year, again, we started where we left off before, so we started in 2017, we started with whatever we ended with at the end of 2016, right? That makes sense. So we started with 21,614. We grew at a rate of 3%. So we took that and multiplied it by 1.03. Finally, 2018, we started where we left off in 2017, and we grew by 4%, and we're left at the end of 2018 with a real per capita GDP of 23,152.92, and we're told we want to round to the nearest dollar. So this 0.92 will round this up, right? So our answer is 23,153. 23,153. Check that. We're good. And then the rest of the question is going to be very similar to the first part. So I'm not going to do the rest here on the video. You should be equipped with what you need to be able to do the rest of this now. But if you do have any more questions, feel free to stop by office hours or to send me an email.